Hi, everyone. My name is Jennifer Shin. As Jonathan just graciously introduced me, I am a senior principal data scientist at the Nielsen Company. And before that, I started my own company, APath Solutions, which I've had about for 5 years or so, and it's a data science, analytics, and technology company. And prior to that, I actually have a lot of experience doing management consulting. So that's kind of where I started in my career. This is, of course, before data science was a word or a term out there. And today what I'm going to talk to you about is empowering your visualization. So I think it's a good topic for this room especially because I'm assuming most of us have an interest in data science, if not that, trying to be data scientists. And so I hope that you can really find some value in this. And so let me start by saying, okay, so data visualization, right? It's one of the hardest things for our industry to describe, right? And it can be difficult to describe because it can encompass so many different types of representations. We have charts, we have graphs, we have infographics, which are generally a combination of charts, graphs, and other visualizations. And then we have heat maps, tree maps, carto maps. Basically, we just really like maps, right? So there's 8 million types of maps that we have. And with so many different types of visualizations, what that tells us is that the impact, the importance, the core of data visualization is far deeper than any single visualization can completely represent. Right? And what makes data visualization really profound is finding the meaning and insight. Right? Finding the meaning, the insight, and in a sea of data, and communicating it clearly as possible to as large and wide an audience as possible. Right? So being able to communicate what's in the data and what's in our visualization is a really important thing that science has been doing for centuries. Right? So what I'm going to ask you to do today is go on a journey. Okay? For data visualization to be effective, data must be transformed into a powerful message. And one of the things we want to think about is what makes a message powerful. And so I'm going to ask you to embark on a journey and think about the power behind data visualizations. Okay? Specifically, the thing we're going to do is we're going to explore, evaluate, and apply visualizations. And we're going to look at it as a lens, right? The lens of exploration, the lens of evaluation and application. And we're going to travel across 4 scenarios. Okay. In the 4 scenarios, we're going to reveal trends. We're going to imagine complexity. We're going to identify failure. And we're going to illustrate issues. And these are things that you will probably come across in your career at some point as important messages to convey to other people, either in your organizations or to external stakeholders, right? Or and sometimes the public. So in the 4 scenarios we're going to describe, you may not necessarily be able to apply all of these. I guess you may be wondering, what am I supposed to think about, right? So I can introduce 4 scenarios to you. And really, where do you start? So questions you might want to think about is, how would you visualize the data? Right. Another thing you want to think about is, what conclusions can you draw from the visualizations presented? And based on the information presented, how would you react or act based on the information given to you? Okay. So in the first scenario, I'm going to ask you to think about a study in which scientists are trying to figure out the cause of recent death in the raccoon population. So we're going to really care about raccoons today. Okay? We're going to forget they have rabies. We're going to forget that they go into your garage and get into things. And we're going to say we really care about raccoons. So we want to figure out why. Why is this population decreasing? Okay? Okay, so we care about raccoons. And so we want to think about, well, what caused their death, right? And so there might be 3 causes, say, in this case. It could be disease. It could be wounds. Or other causes. Okay? And in this data set, basically scientists have collected data over a 3-year period. You can see what it looks like, right? There's a year, there's a month, there's a type, and a count. So what's the best way to visualize this information? I want you to think about, how would I visualize this information to figure out what might be the cause? Well, here's one visualization. And we see it's over time, next axis, and there's a count. Look at the mortality and deaths. Okay. Here's another one where you can see it's different diseases, it's other causes, it's wounds and injuries. And we can see that there's That's an annual mortality. And this one's slightly different. It's very similar to the other one, but in this case, we see that the different causes are on the y-axis. And the annual mortality and deaths is the two different colors in the bars. Okay. So now I'm going to introduce a new scenario to you. So in the previous scenario, we collected a set of data points and basically over a course of 3 years. But what do you do if that data is not available? How would you actually visualize something if you don't have that data? Okay. So this is a relatively simple case in scenario 1. But if that data is not attainable, consider cases where you might be able to visualize complexity in, say, nature. Right? Nature is very complex. That's information that we want to visualize oftentimes. But how do we actually visualize it if, in fact, it is so complex? Right? How do you actually get that data and visualize it effectively? And so here are some examples of visualizations. Right? Things you might want to visualize. There might be a leaf. There might be mountains. You can see there's so many layers of detail in that mountain. So how do we actually visualize that? If we don't have, if you're looking at something, right? Say you're just looking at this podium, you're looking at the stage. How do you get data from that and then actually visualize it? And the third scenario I'm going to ask you to think about is to imagine that you've invested heavily in a new technology and you expect to launch it tomorrow. Okay? So you're interested in having this venture, you're launching new technology, and you've put all your money and all of your life savings into it. Okay. Now, prior to your launch, your engineers have run a series of tests, and on occasion, a component has failed. So the question is, if you've already announced this launch in all your media outlets to the public, do you launch tomorrow? Right? You invested everything you have in it. There have been components that have failed, and you've already told everyone. You've told your mom, you told your dad, you told your sister, you told your friends, you told everyone. But your engineers have now come to you and said, okay, well, there's a problem. These components are failing. Do you feel comfortable launching anyway? Right? How do you figure out, should I launch my new technology? And so the question here is, how do you make an informed decision using data? And also, what data do you collect to be able to make that informed decision? Okay. And so here's an example, right? We have failures and successes at certain temperatures that the component had failed. And you see on the left you have zeros, right? And on the right you have 1. It's basically binary, right? Zeros and ones. And then temperatures on the y-axis. Here's another one. Here we have temperature and failure again. The blue dots are the failure, and the red is the temperature. So again, I want you to think about, does this visualization really help you make that decision? Is this the visualization you would use? And if not, what visualization would you use? And here's another one where we have temperature at the top and failure at the bottom. In this one, we split it up, right? In the previous one, we saw that we put them on top of each other. We overlay it. In this one, we have it separated. Okay, in this case, we have temperature. And now we're representing successes and failures based on the color of the bar. Right. So again, something to think about is which one of these visualizations would you say is the most effective way to make a decision? Or are any of them even? Right? Maybe you think none of them are. Maybe none of these things would make you feel comfortable making a decision. Okay. Now, in the last scenario, the fourth scenario, okay, I want you to think about, a lot of times when we have data, one of the things that we'll do is we'll actually collect a lot of data points, and we'll combine them. Okay. So in this case, we have three data sets, 3 samples. We have X's and Y's, right? And a lot of people would say, okay, well, we collected three sets of samples, and we're just going to combine them to one large data set. Does that make sense to do? How would you visualize this information? So this might be one visualization. If you guys have taken W203, if you're taking statistics, right? Or any statistics class, you recognize this. Right? And you can see that there's little blue dots that actually show the data points. And you can see the mean. Right? And it looks like the data is similar. Right? Is this enough of visualization to make you feel comfortable to say, yes, we can combine these data points together into one set? Can I give you a minute to just think about the four scenarios you just seen, okay? So we've now introduced these scenarios, and now we're going to explore the scenarios. So in the previous example in scenario 1, I want you to take a minute and think about, okay, so we really love raccoons. We really care about their well-being, and we are really devastated, right? Devastated that the population is decreasing. Now, what if we said it wasn't raccoons? So many of you might sit here and be like, I don't really care about raccoons. You know, who really cares? I really care about that data. You know, or maybe some of you saw the visualization and said, like, I feel very comfortable making a decision on this. Now, I want you to think about the fact that maybe it's not raccoons. What happens if we change raccoons to soldiers? Right. The numbers are the same. The deaths are still there. The causes are the same. But now we're talking about soldiers. We're talking about wounded soldiers and people, and not raccoons. Does that now change how you saw that visualization, how you interpreted that information? Right. Specifically, if anyone, I'm sure many of you have probably seen this before. Right. Right. This is Florence Nightingale's coxcomb. And this is a rose diagram. And you know, Florence Nightingale is kind of founder of nursing, as well as some of the other medical fields out there. And what you may not realize about her is that she actually used visualization to make an impact in society, to make a change. So, you see this visualization probably coded in a million articles or online resources, and you've seen it and gone, okay, that's a nice visualization. But have you ever thought about what it was that this visualization actually did in the real world? So, in this case, what this visualization actually visualized is, in fact, the information we saw earlier. Right? So, number of deaths over a 3-year period, the cause of the death, right? And here's a nice image of how she actually visualized that. So what she did was she actually had field results, research of British military hospitals during the Crimean War. And it showed that unsanitary environment caused preventable diseases and more fatalities than other causes such as battle wounds, which is the red that you saw. And it was used to argue for better conditions and quality of care of wounded soldiers. And ultimately, the results were that the conditions improved. The government saw this and actually improved the conditions. So what you may not realize, though, is that, in fact, when she actually presented this initially, presented the information, she actually had a lot of opposition from the medical community. So the top medical officer, the chief medical officer of England, who was Mr. John Simons, basically didn't agree with her. And so the visualization was actually very important because she's someone who's not a medical doctor, and she's disagreeing with medical doctors that this is not the cause. And she's using visualization as a way of proving that, in fact, she's right. So in the second scenario, we looked at how do you visualize nature, right? How do you visualize things where you don't necessarily have the data? Well, I don't know if has anyone actually heard of the word fractal? Anyone familiar with fractals? So fractals are geometrical objects that are self-similar when the distance at which they are viewed is changed. The concept is helpful for allowing order to be perceived in apparent disorder. Right? So when you see, like, a lot of things in nature, it seems like there's a lot of disorder, right? You can't really, there's jagged edges. It's hard to tell, where the pattern is. And chaos and irregularity of the world is what Mendel referred to as roughness. And here's a quote that he had: "Clouds are not spheres, mountains are not cones, coastlines are not circles, and bark is not smooth, nor does lightning travel in a straight line." Mathematically, the Mandelbrot set can be defined as a set of complex values of C for which the orbit of 0 under iteration of complex quadratic polynomials remains bounded. Oops. So what does that mean? Let's see. All right, so we're going to have to do without the visualization. I realized that this is the wrong file, and this is supposed to be a video, which would have been nice to have, but it's fine. So Mandelbrot set, this is what it looks like. And what that allows us to do is actually visualize what we saw as a leaf. Right? And allows people to use a complex mathematical formula to recreate nature. It's a simple equation, and yet you can use that simple equation to recreate the data we have in nature and visualize that information. All right, here's another example. And again, if the video had worked, you would see it actually kind of showing you how that actually works. Okay, like how it can actually create the similar shape of mountains, right? Just by iteration and by using the right equation. Okay. Now the third scenario, if you guys remember, right, it was a scenario where you're thinking about launching a company, a new technology, right? It's tomorrow, and you have, you invested everything you have in it, and you're just not sure if you should because your engineers came back to you and said, I know you're launching tomorrow, I know you told everyone, but the thing is there are components that are failing, right? So now, if you think about it as a concept, or personally, you might be like, well, I still want to launch because I invested all my money, why not? So I want you to think about something called O-rings. So O-rings are basically, right, a piece of hardware that is used on space shuttles. Okay? And they're designed to prevent the release of hot gases during combustion. Okay? So each booster in a rocket contains 3 primary O-rings. So it happens that there are 23 flights for which O-rings were examined for damage. And so it's part of a rocket ship, right? And the day that it's forecasted to launch, it's 31 degrees outside. And the previous coldest day, the temperature was 53 degrees. So there's a huge difference, right? Today you're launching, or tomorrow you're launching at 31 degrees Fahrenheit. All your other tests were at 53. That was the lowest temperature. And O-rings, the sensitivity of O-rings to temperature is actually quite well known. Okay? So the problem with this is that when it's warm, it will quickly recover its shape after compression. But when it's cold, it basically loses that elasticity, that ability to do that. So I'm sure most of you have heard the Challenger disaster. Right. So in 1986, the Space Shuttle Challenger was destroyed on launch. And subsequent investigations showed that an O-ring, that piece of rubber, failed, allowing highly flammable fuel to leak light and destroy the ship. And again, that would have been a video of Richard Feynman, if you guys have ever seen it, explaining exactly how he saw the failure. Right. So when we think about, okay, how do we visualize that data? You saw previously that was binary data, right, zeros and ones. Well, there's other ways that you can actually visualize that data. If anyone's ever heard of a logistic regression, logistic regressions are actually very useful for being able to visualize this information. Right. For instance, right, with the Challenger disaster, when you had just the zeros and ones, right, it's kind of hard to tell, like, all right, at these temperatures, maybe it'll be fine, maybe it won't be. Because you see that there's some temperatures where it was higher and it caused failure. Well, incidentally, if you actually use a logistic regression, you'd find that at that lowest temperature at which the measurement was taken at 53 degrees, the chances of failure was 94%. So in fact, you can calculate what the percentage of failure is at that point. Even though we're not at 31%, we can still calculate what the probability of failure is. And these are, again, visualizations where you can actually see that curve. Right? Rather than just having it be these binary data points, you can actually see that probability. And you can see it goes significantly higher, right, when you're at the lowest point of temperature. And it's close to 100%. So in the fourth scenario, we had data points. And we said, can we actually combine these data points, right? We saw the plots. It looked like the mean was the same. It looked like the distribution was the same. Right? So here are the data points, all plotted on the same chart. So what's the problem with this, right? So they look like they're, they're all fit within the same region, right? The same mean. Well, so Anscombe's quartet, I don't know if you guys have heard of this, but basically he was someone who was working with computers in the 1970s. And he felt that we should still plot data points. We shouldn't just look at the numbers, right? Because at that point, a lot of engineers and scientists were just printing out the numbers, right? So things like what's the mean, right? What's the standard deviation? Things that you would just see as descriptive statistics. And he said, no, I think we should still plot this information. We should actually still visualize it and not just look at the raw numbers, right? And so he came up with 4 sets of identical data, 4 sets of data that looked identical, I should say. But he made sure that they varied considerably when you graphed them, right? So what does that mean by identical? In this case, we mean that the mean was exactly the same for all 4 sets. The variance was also the same. The mean of y, the mean of x, right? Those being the same. The correlation between the x's and y's, right? And then linear regression as well. But then if you actually graph these, so this is the first series, right? The second series, and you see like the line is the same, but you notice that the pattern is very, very different. The third series, again, different. And this was the 4th series that he had. So you can actually see that, in fact, if you were to combine them all into one data set, that you may actually be combining data that, when visualized, is actually very different. Right? So application. So what are the key takeaways that we want to take away from seeing these visualizations? For one thing, taking the data journey, like you did today, is a very important part of not just data science, but data visualization. Right? You have to be willing to let yourself explore the data, not have just preconceived notions, but really think about the real world scenarios, and also the impact of what the data will actually, what kind of change will it make, what kind of limitations are there. And the other things you want to think about is to think creatively, right? Not think about it in the same old ways that, a lot of you might be in classes going, I just need to learn a list of things and I can just go and just apply that and I'm good. Well, you could do that, but you will also run into other issues later on by doing that. Right? If you're one of the engineers who worked in Challenger, and with Challenger, the thing to think about is, that's an issue where it wasn't a data problem per se, right? To some extent, it was a people problem. Right? It was about engineers did, in fact, report that this was a problem, but other people didn't listen to them. Specifically, management and the management at NASA didn't listen to them. Right? And as data scientists, a real challenge you may come across is what happens if you're the engineer and your data suggests there's going to be failure. How do you visualize that data to prove, in fact, it's going to fail, that it is very, very dangerous? And in fact, the engineers who worked on the Challenger, to this day, have a hard time with the fact that the Challenger is blown up, because they felt they could have done more. And it's a very difficult thing to deal with when you did try your best, but people don't listen to you. And the reality is, when you're working with data, and your job is to be a data scientist, it is your job to convey the importance of that data and the impact of that data. In scenarios that aren't going to be so easy to convey that complexity of the information in a simple way. And this is where data visualization becomes a very important tool. So another thing to think about is applying new methods. For instance, we saw the Mandelbrot set. So now, the application of that to many people would have been like, well, I don't really care about, I don't really care about topology. I don't care about, math. But really, there's a lot of really cool applications to that, right? And it actually is a better computationally, right, to use a simple equation and to iterate than to have like every point of that, that image in a data point, right? It's a much more complex thing to actually visualize. And experimenting with data, right? Being able to experiment with it. And that means, for instance, we saw in the 4th scenario, it's not just, you're processing it and you put it together and you're done. It's really looking at the data and seeing, well, what are some scenarios in which this is going to be a problem? In that case, he came up with synthetic data to demonstrate why we should graph the information, why we should create charts. So it's not always about the data that you're given. Sometimes you create data to be able to convey a point, to be able to show that there is an issue with the data that they're working with, or maybe the method that they're working with. And the other thing is building on analytics, right? And so I think in a practical sense, in the real world, many data scientists work with analytics. It's sort of a middle ground for people who are in business and other parts of the company, as well as data scientists, to be able to have a tool for being able to look at data and a method of looking at it without looking at maybe the nitty-gritty granular details. Right. And so you can think about it, it's kind of interesting in that the data can be the input, the visualization can be the input. So what are the outputs? Right? The output is decisions, right? Decisions that get made with it, right? The decisions that the model might suggest that someone take or make, right? And the methods would be analytics in that case, right? It's a model, it's a tool. Okay? It's being able to use the data, use the visualization, and allow people to make decisions with it. Okay, so the real takeaway here, I think, is that visualizations can't just be endpoints. Right? Decisions are the endpoints. And the measure of our success is not the visualizations we create, but how we can get someone to act on them. This is how we make decisions. This is how we save soldiers' lives, or raccoons for that matter. And this is how we prevent catastrophic failure. Right? So this is how data visualization is now, and hopefully in the future. And this is how we should think about our role as data scientists. Thank you.
Thank you. Jennifer, thanks very much. We've got 5 minutes for questions. Anyone want to kick us off? Yeah, we'll take the mic here with Joseph at the front. Thank you.
So all of the visualizations that we got to see there, I guess the Mandelbrot set would have involved something dynamic, but more largely static visualizations. With dynamic and interactive visualizations available, how do you see those being applied? I guess, like, do you see more noise or value from that? And how do you decide what type of visualization to use when you're setting that up?
Well, that's very open-ended, right? So it depends on what your role is, and it depends on whether you're the one who's developing it or the person who's using it, right? So I think that's, if you're the one creating it, then you might want to think about where the pitfalls are, where people might be misled by the data, and kind of construct it in such a way that when they can drill down, it makes sense. If you're the person using it, then I think that's where it's very, very important to understand not only data, but also like methods for working with data, right? So with interactive visualizations, I think the challenge is whose hands it goes into and what they use it for. There's no clear rule for that. For instance, if you're someone who's a real data scientist, you might use that tool to be able to really drill down to the lowest level. Versus if you're a business user, you might have certain tiers built in that someone actually built in as levels of that data. But even in that case, you really need to make sure that the data representation is accurate, because that's really the key in being able to have the right information.
Thanks.
Great, thank you. We've got a question right at the back there in the corner. Thank you.
I just saw you work for Nielsen. I know Nielsen is doing a lot of measurement science, and you do a lot of TV rating, movie rating. For measurement science, when we produce results, have you considered using fancy data visualization tools when you deliver outputs?
So I guess the question would be, do you mean for analysis or do you mean for clients, right? So that's
yeah. For you want to produce a PPT presentation for clients. Have you used any advanced data visualization in your report?
Well, so I can't speak for all of Nielsen, right? Our data science team has about 900 people in it. So it's one of the biggest in the world. So I couldn't tell you what all 900 people have done. What I can tell you is, in terms of, what's interesting about some of the data that we work with, especially when it comes to making a presentation for clients, some of it is actually more narrative, right? Because we work in the media space. So for instance, I have a team of students that I work with at Cornell Tech, and what they're building is what we call a story finder. So it's being able to take data that we actually have, real data, and present target audience information, so segment, right? Like for instance, if they're a coffee drinker, what other things are they interested in? Being able to present that in a narrative way, so showing that information about that group of people, but in a way that marketers can understand, right? The non-data scientists can understand, and that in that sense is an interactive tool, right? So it kind of allows it to be more of a story rather than just here's a graph, right? Because they're not as maybe data, they may not be as familiar with data as data scientists generally are.
So one more question. Sam, you got one at the back there.
Yeah, so I was thinking about when I was seeing your presentation, and thank you, by the way. Earlier in the year, the Harvard Business Review had a sort of overview about visualizations, and they kind of contrast data-driven visualizations with more conceptual visualizations. And I was wondering if, you know, using analytics towards this notion of having an output of making decisions, is it always going to be data-driven visualizations that we're creating, kind of like we've seen today? Or is there a role for more conceptual visualizations where we say, the point that I'm trying to make, I understand it by looking at the data, but the way to get there isn't by necessarily visualizing that data, but something maybe a little bit more conceptual?
So I think, you know, again, visualization, it's hard to describe, right? Because there's so many different kinds, and there's so many different methods and so many different approaches. I think, you know, and I always say this, like, if you're someone in marketing, you might care a lot more about how it's presented, and you probably should care about how, you know, pretty it is. Versus if you're in science, it's less about how pretty it is, it's more about how effectively you've represented the data that you're working with, right? So I think depending on what you're using it for and really who your audience is, right? You really have to keep in mind who the audience is. I think that's going to make a big difference. Like, you can make a data-driven visualization, but if it's for the public, that's generally not going to go over as well because the general public is not going to be as familiar with maybe data-driven methods or, you know, sort of the underlying things that are underlying that. One of the things that I actually visualized in my research was actually the rate of, or the incidences of a birth control pill causing basically blood clots, right, so strokes. And what's interesting about that visualization was that, you know, there's a lot of these models and numbers that we use, machine learning and these techniques, and these numbers suggest one thing. And so they visualized it and it looked like, okay, it was fine. When you actually visualize not the metric, but the actual count, the number of reports that came in for that drug, it showed a very different story than, say, that, you know, that really complex model that we visualized. So I think, you know, that's the other side of it, is that sometimes the simple visualizations that we often neglect because we're so interested in these complex methods that we use can really, you know, that can actually mislead us into thinking that we have the answer. But really, the simple visualization, you know, that might be the key of what we need to be looking at.
Okay. All right, please join me in thanking Jennifer. Thanks.